The U.S. Army Air Corps wants a modern bomber. They want something with the range, the altitude, and the speed capable of delivering a load of bombs on a target. It's their vision of what future war will be.
Former aerodynamics engineer Charles Champion is appointed to oversee the project's toughest stage, building the plane. Champion will have to arrange for all the parts of the Superjumbo to travel to the Airbus assembly plant in Toulouse. After 15 months, he resorts to the unthinkable. A complex convoy of ships, barges, and massive trucks, all converging on southern France. It will demand coordination on an epic scale.
We had to design barges in order to go through Bordeaux, the old bridge, up to Langon. But then afterwards, of course, the river is too small, so we had to go by trucks. So that was a huge project. And immediately, of course, there were many challenges. Where to place the road, and what about the villagers, and this and that.
In the tiny village of Levignac, the massive sections of fuselage almost touch the walls of the houses as they pass. After a combined journey of more than 3,000 miles, the largest airplane components in civil aviation history finally arrive in Toulouse. Here, Charles Champion will oversee the construction of the biggest civilian airliner ever built. January 18th, 2005. The first prototype of the Airbus Superjumbo is revealed to the world in a glittering ceremony.
You see all the stakeholders coming in, the head of the customers, the head of states also.
European premiers, who have invested billions of dollars of public money in the project, gather for the event in front of the world's media.
This is the most exciting new aircraft in the world. It is European cooperation working at its best.
Your heart tells you, my God, this is the best event I will ever probably attend, because I'm the one who was leading the program.
But the star of the show is the plane itself, the Airbus A380.
It's one of those emotional moments where suddenly we realize the size of what you're doing, the level of ambition, the largest aircraft ever in the world.
But behind the smiles, there's just one piece of unfinished business. The Superjumbo is yet to fly.
Since its maiden flight in 2009, the A400M remains one of the most versatile and sophisticated military transports in the sky.
I think 2,700 feet climbing 5,000.
The A400M has a maximum payload of 37 tons, a fuel capacity of over 16,000 gallons, and a flying range of nearly 5,500 miles. The distance from Berlin, Germany to Las Vegas, Nevada.
Heading 055.
With lighter loads, the range almost doubles.
It's also capable to perform tactical missions like medical evacuation flights, aerial delivery, air-to-air refueling.
40, 30, 20.
Designed for extreme environments, the A400M can land on short patches of gravel, sand, or dirt.
We feel committed to make this story a success.
A perfect fit for the demands of Germany's Air Force, the Luftwaffe.
This airplane has the look of a toy, but it's real and ingenious. Nicknamed the Pregnant Guppy, it's wide enough to carry space hardware and comes apart to get that hardware in and out. First, the stages of a rocket. They'll have to put it together like building blocks. Then, a Gemini capsule. Everything looks right out of a kid's toy box. But this is full scale, exceptionally complex, uncommonly expensive. And Gus Grissom, is about to make it really fly. Grissom joins rookie John Young as America's first two-person crew for the maiden voyage of Project Gemini.
4, 3, 2, 1, 0. Ignition.
Gemini 3 pierces into the sky, flying straight and true.
The powered flight was very smooth, smoother than we had any reason to expect, and there isn't a jiggle or a bump in it in the whole first stage flight.
I have your backup times on bank angles and time to reverse bank angles.
Astronaut Gordon Cooper, one of Grissom's best friends, guides them around the globe.
Hello there.
Then, they land 52 miles off target.
We're 50 miles from the spot there.
By the time the Navy finds them, they've been pitching in deep swells for 30 minutes, costing Grissom his breakfast.
Recovery, go ahead. Monitor, we have both Astros and Kilo at this time returning to the carrier. Roger. All well.
The capsule shows the scars of re-entry, but passes the flight test. It's airworthy and airtight. Few know that on the next Gemini flight, they'll open the hatch on purpose in space.
It was actually a kind of secret effort, and the rest is one of the most extraordinary episodes in the whole history of NASA.
The helicopter's rotor blades boast a massive 56-foot span. Try to squeeze the S-92 on board, and there will only be one outcome. So Dan's team must take the blades off one by one, handling them with extra care. Easing the pins loose, making sure not to score or twist them, and keeping the highly tuned aerofoils dent-free. Only then can the S-92 begin the rest of its journey.
What they'll have to do is take off all the blades, the tail rotor. You can see the protection going on right now for some critical parts so they don't scrape paint.
First task, take off the rotor blades. They'll use a crane to take the weight of each blade. They must keep them perfectly positioned so their pins slide out without a struggle.
We have liftoff, Houston.
Position. Yep. Okay, I got the bomb.
Each blade is worth $500,000. A dent in their precision-engineered aerofoils could affect the S-92's ability to fly.
Shot. Try lagging the blade a little bit. Okay, hold it.
Lead it.
Blade's coming out. You guys got it.
Let's hope the other two go as smoothly as the first.
It takes 30 painstaking minutes to remove each blade. Last task, remove one of the rear rotors.
Yeah, you've got two on there. There might be a third. The blade will slide right out of the cuff. Watch the pitch link.
Each of these blades is worth $210,000.
Damn it.
Holding this in your hand is about the equivalent of holding a Dodge Viper or a high-end Corvette. So we want to make sure as well that this is equally as protected as the main blades.
We got a piece of
styrofoam that we put on here to help protect the aircraft. No scratches.
It's an extraordinary amount of wrapping and packing. But it's the only way to give the precious helicopter a fighting chance of squeezing into the Antonov without a scratch.
Getting under the skin of a C5 really gives you an appreciation for the engineering. The paint alone is 2,600 pounds, but when you have that removed, you can see all the rivets and fasteners it's actually used to put this thing together. When you add them up, it's over 1.6 million. To really appreciate the size of a C5, you've got to get inside. This cargo compartment measures 19 feet wide, 13.5 feet tall, and over 143 feet long, which is longer than the Wright brothers' first powered flight at Kitty Hawk, North Carolina. This allows a C5 to carry more troops and supplies than any other airlifter in service today.
The cargo hold was the breakthrough that won Lockheed the contract, but building it was a serious challenge. To begin with, access. Giant cargo needed a giant opening. But the front of any plane is blocked by the cockpit. The solution? A nose cone that swings up to become a massive door. It's called the visor.
I've seen this open and close 20 times, and it's still an amazing feat of engineering.
20 feet wide and weighing in at over 6,500 pounds. The visor swings up 65 degrees to clear the cargo bay and sit above the cockpit during loading. At the rear, another colossal door, 23 feet long and 18 feet wide, creating an open-ended drive-on, drive-off cargo hold the size of a bowling alley.
So this is the back end of the cargo bay, and just to give you an appreciation for how big this is, you could actually fit 58 Cadillacs inside of there.
The C-5 was the only aircraft that could deliver two 65-ton battle tanks directly into a theater of war. It could also transport mobile bridges, armored personnel carriers, troop trucks, and just about anything an armored brigade would need on its deployment. It was a game changer for U.S. military long-distance operations. The visor was a creative solution to one of the problems of building a plane on this scale.
Jay Carter of Carter Aviation Technologies is the first engineer to successfully use slowed rotor technology.
The advantages of slowed rotor compound is that it gives us better speed, better efficiency, and better safety than any other aircraft.
His first prototype was called the CCTD, for Carter Copter Technology Demonstrator.
It's an aircraft, it's a gyro, it's a helicopter, it's a hybrid. By combining all three of these, we got an aircraft that can take off and land vertically like a helicopter, yet fly as fast and as efficient as a fixed-wing airplane.
Rotors, especially on gyroplanes, create enormous drag, which limits airspeed. It took Jay 7 years to work out what had to be done with the rotors for high-speed flight. And on June 17, 2005, he proved what everyone had said was impossible. He slowed the rotor down enough to almost eliminate any drag, thereby increasing his airspeed. He achieved what's called mu1, where the airspeed equals the rotor tip speed.
The advantages of mu1 are the fact that we've been able to slow the rotor down so much that it now basically disappears. From a drag standpoint, it basically disappears.
Nobody had ever done this before.
After we broke mu1, we ended up on the very next flight having an accident. And nobody was hurt, but we did pretty well tear up the aircraft.
Fuel filler cap.
Today, Jay's team is flight testing the latest prototype.
All surfaces.
Good.
Propeller and spinner.
Good.
You ready?
Okay.
Ready?
Yep.
Clear.
The vehicle can either take off with a short taxi run, or it can take off vertically. That's not what gyroplanes normally do.
So when we spin this rotor up like this, there's a whole lot of stored up energy, like a flywheel. And so we literally can jump in the air on just the stored up energy that we have in the rotor blade.
Over the next year, Jay will keep testing his prototype and improving his slowed rotor system. After that, he plans on scaling up the challenge.
Today, only 50 airworthy Spitfires survive. Maintaining one of these aircraft costs tens of thousands of dollars a year. Tom bought the aircraft for almost $2 million and invested over $300,000 more, restoring it to its former glory. Aviation experts John Romaine and Mo Overall led the project. Now, Tom wants Mo's team to bring the Spitfire home to Easton for him to fly. Mo's team decides to dismantle the Spitfire and ship it to America inside a cargo container. The move will cost Tom nearly $40,000. The team's main concern is, will the Spitfire still be fit to fly when it arrives?
You run the risk that every container is going to be banged or knocked at some point in that shipping process. There's the road transport, ships, the craneage. I mean, the worst case scenario is that the container actually rolls over, and then you really are into a lot of damage.
The first task we do when dismantling this aircraft is we'll remove all the main panels. Splendid.
You have to bag up the screws so you know where they go, because every screw is different.
Every component that's taken off is checked and cleaned and wrapped up. When you're working away from base, you don't want to find any part that's damaged.
So when you get to the other side, it's straight on and you know it's okay.
With its innards exposed, they can begin to take the Spitfire apart. Its unusual design makes this difficult.
The problem with the Spitfire is that the wings carry the undercarriage legs. So once the wings are off, the fuselage is completely immobile.
As the team removes the wings from the fuselage, they also take away the plane's only form of support, making it dangerously nose-heavy. To stabilize the Spitfire, they will take off the heavy propeller first and build support towers under the plane's fuselage, nose, and tail. Extra towers will prop up the wingtips. With the aircraft balanced, they'll use cranes to lift off the Spitfire's wings. With the towers in place, they carefully remove the Spitfire's propeller.
With the propeller on and the aircraft on jacks, it's quite tail-light. You have to be very careful that it doesn't tip on its nose.
The slightest dent on the propeller blade could fundamentally damage the aircraft's flying performance.
Right.
The crew has to carefully remove the Spitfire's wings to fit it inside the crate. They'll lift the half-ton wings up with straps. To prevent the straps from tearing into the underside wing panels, they protect them with padded wooden beams.
It's always a bit nerve-wracking when the wings come off. We have to make sure everything is trestled very carefully because it's quite unbalanced, the aircraft.
Up.
OK, up and down. Get ready, because I don't know quite what it's going to do.
Right, here she comes.
Here it comes. The wing is the most difficult part to take off because it's awkward to hold and it's awkward to handle and it's also very heavy.
Okay.
Splendid.
One wing down, one wing to go.
Okay.
Yeah. There it comes.
April 2005, bright day in Toulouse. 40,000 people around the fences of the airport to see this. Quite an event for us. The first flight of the A380.
Flight test engineer Fernando Alonso knows how dangerous this moment can be.
When you fly an airplane for the first time, things can go wrong. There's no time to think what to do when you're up in the air. So you better have thought about what you're going to be doing before you actually take off.
At 10:29 a.m., under a cloudless sky, the A380 accelerates down the runway. The huge machine lifts effortlessly into the sky.
Before you got a chunk of carbon, aluminium, and sitting on the ground, and then suddenly when she flies, I mean, she's alive.
It flew incredibly well. It flew beautifully from, I would say, from 1 minute after liftoff.
We had imagined this moment for years and years and years, and suddenly it happens. Wonderful day that I will remember all my life.
After 4 trouble-free hours, the A380 touches down and enters the record books as the heaviest flight in commercial aviation history. Over the next 19 months, the plane undergoes 2,500 hours of flight tests. These are an essential part of aircraft certification. But for the A380, they also serve another purpose: convincing the public that flying on such a huge plane is safe.
There was a public perception of, isn't it going to be dangerous? All those many people on the airplane? And yes, this airplane was big, but it was just another airplane, and it had to be handled and could be operated like any other airplane. It just happened to be bigger, that's all.
The test pilots pushed the A380 to its limits.
We went to very hot climates, went to very cold climates. We brought the airplane to its structural limits. We brought the airplane to our aerodynamic limits.
In one test, in order to identify the minimum takeoff speed, pilots deliberately dragged the tail along the runway. The A380 passes every test with flying colors.
The B-17 was an outgrowth of military strategies following the First World War, where armies hunkered down for months in the trenches, battling in the mud, fighting for inches of territory at the cost of millions of lives. By the mid-30s, the demands for a supreme military weapon take shape.
The U.S. Army Air Corps wants a modern bomber. They want something with the range, the altitude, and the speed capable of delivering a load of bombs on a target. It's their vision of what future war will be.
In 1935, the Boeing company develops a breakthrough 4-engine, long-range aircraft that can carry a 2-ton bomb load and is heavily armed, the B-17. The excitement generated by the B-17 leads many air power advocates to claim the bomber could fly anywhere, unescorted. In flight, the B-17 is a formidable fighting machine, operated by a 10-man crew, each one with a specific job.
In the front of the airplane, you have the bombardier. His job is to drop the bombs in the bomb bay in the center of the aircraft on the target. The navigator's job is to guide the airplane to the target. The 2 pilots right behind them guide the airplane, operate it, fly it. The radio operator on a B-17 performs the critical function of communicating with the other bombers in the formation. For the rest of the airplane, it's all about the defensive armament and employing that in defense of the airplane. The top turret gunner the waist guns, the ball turret on the bottom, and the tail turret all defend the aircraft against enemy attack.